Hi there. Today we're going to discuss quartile deviation, or what is commonly called the semi-interquartile range. This is a measure of dispersion that quantifies the spread of data around the median. In my last video, I explained that the range is the simplest measure of dispersion. It is easy to define and calculate, and because it is affected by outliers, it's not always a satisfactory measure of variability. In this video, you will see why the quartile deviation is a better measure of dispersion. So let's consider this data set representing the ages of pediatric patients on admission in a secondary healthcare center in Zaria. Let's calculate the quartile deviation to explain the dispersion or spread of the ages of these patients. The quartile deviation is obtained from the interquartile range by dividing it by 2. Hence, it is called the semi-interquartile range. Semi here meaning half or divided by 2, right? It's given by the formula QD is equal to interquartile range divided by 2. Easy, right? Interquartile range is Q3 minus Q1. Alright, so we can say QD is Q3 minus Q1 divided by 2. Q3 here is the upper quartile and Q1 here is the lower quartile. To do this, we will need to first compute the quartiles, then find the interquartile range before we can now divide by 2 to get the quartile deviation. Alright, so we'll need to follow just 4 simple steps. First off, arrange the data in order, then we compute the quartiles, and we calculate the interquartile range, and lastly we divide it by 2 to get the semi-interquartile range or the quartile deviation. So with this data, the first step is to arrange the data in ascending or descending order. I prefer to arrange in ascending order, so let's go. Awesome. Now, the next thing to do is to compute the quartiles. I have made an extensive video on how to compute and interpret quartiles. I'll leave a link in the card above or in the description of this video. So to compute quartiles, it's easier to start with the median, which is the second quartile. So since we have 11 data points, the middle data point is... Alright, so let's start cancelling out from both sides. So here and here, then this and this are great. So the middle data point is 6. So our second quartile, Q2, is 6, and this is the same thing as the median of the entire data set. Now let's go to Q1. For Q1, this is the median of the lower half of the data set. So if we have 2 points here and 2 points there, then our middle data point is here, right? So our Q1, which is the first quartile, is 3. Nice. So let's find Q3, which is the middle data point in the upper half of the data, or the median of the upper half. Alright, so we have 2 points here and 2 points here, just like when we did Q1, and Q3 is going to be here. So our Q3 is 9 years. So our Q1 is 3 years, our Q2 is 6 years, and our Q3 is 9 years. Awesome. We will now go to our third step, which is to find the interquartile range. The interquartile range is the difference between the upper and lower quartiles, which is the difference between Q3 and Q1. So IQR, that's the interquartile range, is equal to Q3 minus Q1. So we'll say IQR is equals to 9 minus 3, that's equal to 6. So our interquartile range is 6. Awesome. Now let's quickly go on to the last step, which is to compute the semi-interquartile range or the quartile deviation. Remembering our formula, quartile deviation QD is equals to Q3 minus Q1 all over 2, or the interquartile range divided by 2. So, and that will give us 6, our interquartile range is 6, divided by 2, and we'll have 3. So our quartile deviation is 3 years. Awesome. So what does this mean? Well, it's easy. Let me explain. This means that the middle half of the data values from Q1 to Q3 is within 3 years of the median. So what we're saying in essence is 50% of our data points are between 6 minus 3, which is equals to 3, and 6, that's the median, right, plus 3, which is equals to 9. And the other 50% of the data are either below 3, that's Q1, or above 9, that's Q3. So what does this quartile deviation actually tell us? It tells us how much the data values around the median vary or are spread out. A small quartile deviation means that most of the data values are close to the median, and a large quartile deviation means that most of the data values are far away from the median. So quartile deviation gives us an idea of how consistent or how variable the data values are with respect to the median, right? So if we compare two data sets with the same median, or different quartile deviations, we can say that one with a smaller quartile deviation has less variation and more consistency than the one with a larger quartile deviation. And don't forget, this is with respect to the median. Great. So remember, I started by saying the range is not a good measure of dispersion because it's affected by outliers. And the answer to the issue of outliers can be solved by computing the interquartile range, which is the difference between the third quartile and the first quartile. And calculating the interquartile range minimizes the instability of the range as it only measures the spread of the middle 50% of the values in the data set, excluding the outliers or excluding any possible outliers. While the quartile deviation, also known as the semi-interquartile range, then tells us specifically how the middle 50% of the data are dispersed around the median. So in the case of our data, we can say the middle 50% of our data is within 3 years of the median. Awesome. Now, if you've gained value with this video, please give this video a thumbs up and share with your friends and colleagues to help them. And if you'd like to see more videos like this in future, then consider subscribing to this channel and click the notification bell icon to get notified of my new videos. In my next video, God willing, I'll be showing you how to determine the quartile deviation for group data. And as always, thanks for watching.